Hi there, this is Pavan, and today I have an exciting video for you. We are going to dive deep into the world of infrastructure as code and unveil some of the best practices for working with Terraform. Without further ado, let's jump right into it. The first best practice: treat Terraform code as any application code. As you know, Terraform is a powerful infrastructure as code tool used to automate the provisioning and management of infrastructure resources. While it is primarily focused on infrastructure, treating Terraform code as any application code brings several benefits. In this slide, we will explore why treating Terraform code as any application code is crucial and how it can improve your infrastructure provisioning process. Firstly, utilizing version control is crucial. By using Git repo, we can effectively track changes, enable collaboration, and maintain a history of modifications. This allows for better teamwork, easier troubleshooting, and the ability to revert to previous versions if needed. Next, following standard software development lifecycle processes is essential. Implement practices such as pull requests, code review, tagging, and releasing to ensure code quality, maintainability, and proper collaboration among team members. Next, adhering to the case. Keep it simple, stupid. Principle is another a vital best practice. Keep your Terraform code concise, readable, and maintainable. Avoid overly complex logic or unnecessary complexities that can hinder troubleshooting or further modifications. Next, embracing the DRY, don't repeat yourself principle is equally important. Avoid duplication of code by promoting code reuse, utilize modules and shared code snippets to enhance efficiency, maintainability, and consistency across your Terraform code base. Maintaining a consistent file structure is also crucial. Organize your Terraform code in a logical and consistent manner to enhance readability and ease of navigation. A clear file structure simplifies maintenance, collaboration, and future expansions. Next, best practice: Terraform state. Terraform state is a critical component for tracking and managing infrastructure changes. Following best practices for Terraform state management ensures stability and scalability. In this slide, we will discuss key practices to store and manage Terraform state effectively. First, store the Terraform state remotely. Utilize options like S3, Terraform Cloud, or GCS depending on your environment. Storing state remotely provides durability, accessibility, and collaboration. And also, remote state enables teams to work together and ensures consistency across deployments. Next, enable locking for parallel execution prevention. Enable locking when using remote state storage. So, locking prevents parallel execution and conflicts, and it ensures that only one user or process can modify the infrastructure at a time, which is avoiding race conditions. Next, enable versioning for state management. Enable state versioning to track changes over time, and versioning provides a historical view of the infrastructure state. And also, it helps the auditing, troubleshooting, and rollbacks if necessary. The final one is never save Terraform state files in a Git repo. Terraform state contains sensitive information and can be large in size. Storing state in Git can lead to security risks, conflicts, and performance issues. Now, let's go to the next best practice: versions lock. In Terraform, versions lock is an important practice for ensuring consistency and reproducibility. Let's explore the significance of versions lock and how it enhances your infrastructure management process. First, what is versions lock? Versions lock refers to pinning the versions of Terraform modules and providers used in your configuration. It ensures that your infrastructure is always built using the exact same versions of dependencies. Next, benefits of versions lock. Consistent deployments. With versions lock, your infrastructure is built consistently, avoiding any unintended changes caused by dependency updates. Reproducible environments. By pinning versions, you can easily reproduce your infrastructure environments across different stages or team members. Next, prevent breaking changes. Versions lock helps prevent unexpected breaking changes caused by updates to modules or providers. Next, implementing versions lock. Use module versions, provider versions, and also leverage version constraints like utilize version constraints, example greater than equal to or less than, to allow updates within the specific ranges while maintaining control. Next, managing versions lock. Leverage dependency management tools like Terraform's Terraform init command or external tools like Terraform Cloud or private registries. Automate version updates. Regularly review and update modules and provider versions to take advantage of bug fixes and improvements while ensuring compatibility. Let's go to the next best practice, modules. Terraform modules are a powerful feature for reusability and organization. Let's explore the significance of modules and how they improve your infrastructure provisioning process. What are modules? Modules in Terraform are self-contained units of infrastructure code that encapsulate resources and configurations. They promote reusability, modularity, and abstraction, making your code more manageable and scalable. Next, benefits of using modules. It helps code reusability, simplifying the infrastructure, scalability, and consistency. What are the best practices for module design? Single responsibility principle. Design modules with a single well-defined purpose, focusing on a specific resource or functionality. Input variables. Utilize input variables to make modules more flexible and customizable. Output values. Use output values to expose relevant information from a module to the calling code. And then important documentation. Documentation. Document modules with clear descriptions, examples, and usage instructions to enhance their usability. Now let's go to the next best practice, tagging resources. Tagging resources is crucial for effective management organization in Terraform. Let's explore the significance of tagging resources and how it improves your infrastructure governance. Importance of resource tagging. First, importance of resource tagging. Enables better organization, tracking, and management, and also facilitates cost allocation, security, compliance, and troubleshooting. Next, recommended tagging strategies. You can have consistent naming conventions, relevant tag keys, and appropriate tag values. Next, automating tagging with Terraform. You can utilize input variables, leverage data sources, and integrate with external tools. Now, let's get into the next best practice, Terraform execution. Remote execution of Terraform brings advantages and improves workflows. Let's explore the benefits and how it enhances collaboration and scalability. Benefits of remote execution: improved collaboration, centralized state management, scalability, and concurrency. Leveraging infrastructure code pipelines. You can use IaC pipelines, with CI/CD integration, followed by testing and code review. Next, considerations and best practices for the remote execution. You need to look at security and access control, versioning and rollbacks, followed by monitoring and logging. Now, next, get into the next best practice, lifecycle block. Utilizing lifecycle blocks in Terraform provides control over resource management and operational tasks. Let's explore the significance of lifecycle blocks and how they enhance the protection of stateful resources. First, resource lifecycle management. Lifecycle blocks enable defining custom actions and behaviors during resource creation, update, and deletion. With that, implement specific dependencies, initialization tasks, or cleanup actions for stateful resources. Next, fine-grained customization. Utilize lifecycle blocks to set up advanced behaviors tailored to stateful resource requirements and prevent automatic updates, trigger specific tasks, or handle dependency during resource changes. Next, enhancing resource protection. Lifecycle blocks ensure proper management and protection of stateful resources with defined initialization tasks, avoid accidental updates, and perform cleanup during resource deletion. Next, best practice, multiple environments. Terraform workspaces simplify managing multiple environments. Let's explore their benefits and how they enhance environment segregation. Utilize Terraform workspaces. First, utilize Terraform workspaces. Create isolated environments within a single project, separate configuration and state for each environment. Next, different configurations. Customize configurations per environment, maintain a modular code base for flexibility. Next, different backends. So you can have a select appropriate backends for each environment and then manage state effectively. And also you can have a different versions. Use different Terraform versions as needed, balance stability and new features. Next, best practices for security. Security is paramount in Terraform deployments. Let's explore key practices to enhance Terraform security. Use a remote state, encrypt Terraform state. Next, implement secrets management. Avoid storing secrets directly in the state file. Utilize a dedicated secrets management solution to securely store and manage sensitive information. Next, explicitly mark sensitive outputs. Mark sensitive outputs explicitly to prevent accidental exposure. Clearly label any output containing sensitive information to ensure proper handling and protection. Next, ensure separation of duties. Define clear roles and responsibilities among team members. Enforce access controls and separation of duties to limit unauthorized access and prevent single point of failure. And finally, pre-apply checks and continuous audits. Run pre-apply checks to validate configurations and identify potential security risks. Implement continuous audits and monitoring to proactively detect and mitigate security vulnerabilities. Conclusion. Following Terraform best practices offers several key benefits. Infrastructure consistency ensures consistent configurations, reducing inconsistencies and issues. Collaboration enables effective teamwork through code reviews, version control, and CI/CD integration. Scalability scalability designs that can easily manage and expand infrastructure as your organization grows. Risk mitigation identifies and prevents mistakes, reducing vulnerabilities and outages. Reusability and modularity encourage code reuse, standardization, and faster deployment cycles. Implement remote state and encryption for enhanced security. Facilitate regulatory compliance and provides an audit trail of changes. optimize resource utilization, and reduce costs. Future proofing adapts to future updates, ensuring compatibility and easy adoption. And finally, framework for success. Streamline infrastructure management processes for overall success. By following these best practices, we achieve consistent, collaborative, scalable, secure, and efficient infrastructure deployments while mitigating risks and ensuring compliance. Let's embrace these practices to enhance our Terraform deployments and drive success. Thank you all for joining me in today's video on Terraform best practices. I hope you found it informative and valuable. Before we wrap up, I want to take a moment to express my gratitude for support and engagement. If you enjoyed this video and found it helpful, please consider giving it a thumbs up and subscribing to my channel. By subscribing, you will stay up to date with future videos on similar topics. Once again, thank you for watching. Until next time, take care, stay curious, and keep learning.